Okay, we got this whole problem. All my work there is showing all the whole time. I'm just going to talk through the steps here of what I did. Now, when a particle is moving along the x-axis and it's asking when is it farthest to the right or farthest to the left, it's asking you to like maximize or minimize that problem, like greatest amount, least amount. So when you're supposed to do that and you have a closed interval, this is what we're going to use is this process where we're going to use a 3.1 absolute extrema process. You're about to make an XY chart and you got to check the endpoints of your interval and your critical number. So if you look at my part A in this upper left corner here, they gave me the original function. So I first had to take the derivative to get my critical number. So I had to do a product rule. So I did first times root of the second plus the second times root of the first. Remember, you do the derivative, e to that power, you go e to that power times the derivative of that power. And then I factor out, I did a GCF, factor out a e to the negative t. And then you're going to set each one of these factors equal to 0. Now remember, your e to the x graph is never equal to 0. So like, remember your e to the x graph will look like this. And so it never crosses the x-axis. Or if you have a e to the negative x or a fraction, it's never going to cross the x-axis. So you don't have to worry about that part of it. But this part here, when you set this equal to 0, I move the sign over. That's where my sine and cosine are equivalent to each other. And you know the sine and cosine are equal to each other where that pi over 4 is your reference angle. And they both have the same sign in quadrant 1 and quadrant 3. So that's pi over 4 and 5 pi over 4. Another way you can think of this, if you divide both sides by cosine, you're going to get where is tangent of t equal to 1. Right? So just divide both sides by cosine, you get tangent t is equal to 1. And then, hey, my tangent is positive in quadrants 1 and 3 from your all students take calculus. And then your reference angle is the pi over 4. So your quadrant 1 is pi over 4, quadrant 3 is 5 pi over 4. Those are your critical numbers. And you have to make a normal XY chart, not an XYY prime, because you're finding like an absolute maximum and it's got a closed interval right there. It's not talking about a relative max or a relative min. So you're going to make a normal XY chart and you're going to plug in the endpoints of your interval, the 0 and the 2 pi, also with the critical numbers there. So all 4 of those you have to take and plug those in place for the t into that original function right there. Now, when we plug in 0, e to the 0 is 1. And then sine of 0, we should know is equal to 0. So e to the 2 pi, you're going to get some number there. But when you do sine of 2 pi is equal to 0 for both of those. And when you plug in, now this is a no calculator problem, but they made us able to tell without the calculator, right? So when you plug in pi over 4, you get this e to the negative power 4, which I dropped down to the bottom. And then you get this sine of pi over 4, which is the square root of 2 over 2. When you do 5 pi over 4, you get e to the negative 5 pi over 4, which I dropped down to the bottom. But when we do the sine of 5 pi over 4, that's in quadrant 3, so it ends up being a negative radical 2 over 2. Now, without the calculator, they had to make it somehow where we could tell, because we don't have the calculator to plug it in and get the decimal numbers. But see how this one's going to be a positive y value, this is a negative y value. This is the lowest y value, so that's your min. So that's going to be, or technically it's like your normal x position. So you're going to be over to the left of the origin there. That's where you're going to be farthest to the left. Now they say what is the value of the maximum or what is the min, then you're right there. But if they say find the time at which that occurs, then they want to know what that time period is. That's at the 5 pi over 4. So always make sure you read what they're asking for right there. Part B, we're going to use a little bit of just blunt force. Just plug the stuff in, make it work, right? When you see this differential equation, we already know the original function. So right away, I could take that guy, plug it in there. We also already know the first derivative. Here's my first derivative. So I'm going to take that guy, plug it in for x prime. What I don't know yet is the second derivative. So I went here, this is my first derivative, and I'm going to do the product rule with that to obtain that second derivative. So I did first times derivative of the second plus the second times derivative of the first. And so all I did was the product rule with that, make sure we're trying all this on our own. Then I distributed, and when I distributed, I noticed that these terms canceled out, combined like terms there. Here is my second derivative. Now all you're gonna do is take everything, plug it into this equation right here. So I had the A, there's my A, then I plugged in the second derivative. Then I did plus, plugged in that first derivative, went right there, and I did plus, took the original function, plug that in right there. And when I distributed this part here, these terms end up canceling out. And I just carried that down, and I did a factoring. Factor out the E part, factor out the cosine part, Now, when I set this thing equal to 0, because it says equal to 0, technically I know that e to the power is never equal to 0. The cosine is equal to 0 somewhere, but I don't care about that because it just says find the value of the constant a, right? So I don't care about where this cosine is equal to 0. It's not asking me to technically solve the whole equation. I just want to know what the value of a is. So that also involves taking this expression here, setting that equal to 0. I set each thing equal to 0, including that one. And then that a is going to be that positive 1/2. And then that's all we were trying to figure out. So we are done. Lemons.